Alright, this is Solving Rational Equations 2. If you have not seen the first video, I strongly suggest you watch that first to get the basics, and this is a little bit more advanced than that. So we're going to solve the equation, and most importantly, we want to check our solution or solutions. So a lot of how we do these problems is, a lot of reason students don't like these problems is it involves fractions. So the first goal here is we're wanting to eliminate fractions. So to do that, we're going to focus on the denominators and come up with what would be our least common multiple or our common denominator. Those are the same thing. So first goal is to come up with the least common multiple, which is our common denominator. Now all or both of my fractions there, the denominators are factored. You know, this one is x minus 4, that one's x, those are factored. So when I make my list of my common denominator, I'm just listing out like I would with addition and subtraction. So I need an x minus 4, and I also need an x. Remember, this is our least common multiple, also our common denominator. So I need an x minus 4 and an x. Now that is as far as the addition and subtraction similarities go. So to get rid of these fractions, here's what I'm going to do. The equal sign is right here. I'm going to take this common denominator. I'm going to multiply the entire left side by this, and I'm going to multiply the entire right side by this. Now you'll see how that's going to be helpful to us here in 1 second. So if I take x minus 4 times x times this piece, multiply this piece, x minus 4 times x, and then on the right side, have x minus 4 times x. Now the reason that's so beneficial is here in this first fraction, I have an x minus 4 both on top and on bottom. So just like with simplifying fractions, we can do that. So all I'm left with is x minus 3 times x. So x times x minus 3. If you distribute that through, we're going to get an x squared minus 3x. On the next piece, I don't have any denominator, so nothing is going to be crossed out there. So I just have to multiply this all together. So it might be a little bit difficult. You can multiply the 4 times the x minus 4 first, then multiply by the x. So 4 times x minus 4, you would have 4x minus 16 times x. And then distribute the x through, you're going to get 4x squared minus 16x. And then on the right side, I still have a fraction there. I have an x on bottom, and I have an x up top. So all I have is a 3x times x minus 4, which is 3x squared minus 12x. So by getting rid of fractions, I get this huge equation here. Now what I'm going to do is on the left side, this is a little bit big. I'm going to clean this up by combining like terms. So my x squared and 4x squared becomes 5x squared. Negative 3x and negative 16x is negative 19x. Still have 3x squared minus 12x on the right side. Only thing left to do is I'm looking at this, I need to solve for x. When I see x squared terms, the first thing I'm thinking about is I got to get this set equal to 0 and solve by factoring. So I'm going to take this x squared and we're going to move it over here. I'm going to take this negative 12x, I'm going to move it over here. So I'm going to subtract 3x squared. I'm going to add the 12x. And again, the reason I'm doing that is I want the right side to be 0. So on the left side, 5x squared minus 3x squared is 2x squared. Negative 19x plus 12x is minus 7x. So looking at this piece, I have to factor this. What I'm seeing there is there's actually a GCF, because remember that's the first thing I'm going to check. Both of these terms have an x in common. So if I pull an x out, I'm left with 2x minus 7. That is what is left over. So x and 2x minus 7 are my two factors. Take each of those, set them equal to 0, and solve. So I have x equals 0, 2x minus 7 is equal to 0, so you would add the 7, and you would get x equals 7 over 2. But we're not quite done. I do not want to circle these yet. What we have to do, again, is we have to check our solutions. So I'm going to show you how to do that. So I got to check when x equals 0, see if that works, and x equals 7 over 2, and see if that works. Now remember, our original equation is x minus 3 divided by x plus 4 equals 3x divided by x. So if I plug in 0, I'm going to have 0 minus 3, 0 minus 4 plus 4 equals 3 times 0 over 0. Now, there's a lot you can do there, but the one thing we're looking to avoid with fractions is we do not want a 0 in the denominator. So over here, you're going to have, negative 3 divided by negative 4 plus 4. So you're good on the left side, but on the right side, we got a problem. We are dividing by 0. We cannot have that. So what I know is x equals 0 is not going to work. That is not going to be one of my solutions. So we're done with that because I ran into dividing by 0. And besides, I'm going to get some number over here. What is that going to be? That's going to be 4.75 if you went the fraction route equals 0. But you can't even divide that. 0 divided by 0. That doesn't work. So we know x equals 0 is not a solution. So now let's check 7 divided by 2. 7 divided by 2 minus 3. 7 divided by 2 minus 4. Plus 4 equals 3 times 7 divided by 2 divided by 7 divided by 2. So what I'm going to do with that one is I'm going to use the calculator to get me through a lot of this. So I'm going to type the top here, and I'm doing this off screen here. So I did 7 divided by 2 minus 3. So the numerator is 0.5, and then 7 divided by 2 minus 4 is negative 0.5. Well, 0.5 divided by negative 0.5, that's negative 1 plus 4. So the left side, we're going to get 3. So now we just have to check the right side. But look here, we got a 7 divided by 2 both on top and bottom. So piece for a piece, and you just get 3. So we got 3 equals 3, which means x equals 7 divided by 2 is a solution. So it's very, very important once you solve these that you go all the way. So we had x equals 7 divided by 2. You got to go all the way and check to make sure your solutions work, because one of them might be extraneous and the other one will be your actual solution. And that is solving rational equations 2.